Something formed at the dawn of time that shouldn't be there. A supermassive black hole, 40 million times the mass of our sun, sitting inside a galaxy that had barely begun to exist. The universe was less than 500 million years old, and it should have been impossible. This is the story of an object that broke the timeline. For decades, our best models of black hole growth told us the same story. Start with a stellar remnant, a dying star, collapsing, a few dozen solar masses, then feed it, slowly, over hundreds of millions of years. That gives you a black hole big enough to matter. But the universe never had that much time. Not this early, not for something this heavy. The Big Bang happened 13.8 billion years ago. For the first 380,000 years, the universe was opaque, a hot fog of ionized hydrogen and helium. No stars, no galaxies, no light that could travel. The universe itself was still hot enough to hold protons and electrons apart. Then it cooled. The fog cleared, and for another 100 million years there was only darkness. The cosmic dark ages. The first stars finally lit up around 200 million years in enormous, short-lived, hydrogen-burning giants. They lived fast, died faster. Some of them collapsed into stellar black holes, a few solar masses each. That was the raw material. And to grow a supermassive black hole from those seeds takes time. A lot of it. The math has always demanded at least 1 billion years of steady, uninterrupted feeding. That is what the Eddington limit sets. The maximum rate a black hole can pull matter inward before radiation pressure blows the fuel away. It caps the growth. It sets the clock. In November of 2023, a team at the Center for Astrophysics released a paper in Nature Astronomy. They had been staring at a distant galaxy cluster called Abell 2744, Pandora's cluster. Its gravity bends the light of anything behind it, a natural magnifying glass built into space itself. Without that gravitational boost, JWST and Chandra could not have seen UHZ1 at all. Behind that cluster, JWST spotted a small red galaxy, and Chandra, the X-ray telescope, spotted something inside it, an X-ray point source, buried at the galactic center. The object was cataloged as UHZ1. When they measured its distance, the numbers came back wrong. Or rather, the numbers came back correct. And that was the problem. UHZ1 sits at a redshift of 10.3. The light we see left it when the universe was only 470 million years old, roughly 3% of its current age. And the X-ray signature told them the object at the center was a black hole, not a small one, somewhere between 10 and 100 million times the mass of our sun, sitting in a host galaxy that itself was barely built. The black hole was as massive as the galaxy around it. Not 1/1000th of the galaxy's mass, the ratio we see nearby. In the local universe, black holes are dwarfed by their host galaxies. That ratio has always been part of how we thought galaxies and black holes co-evolved. A ratio close to 1:1. That is not how black holes are supposed to grow. There are 3 ideas. The first is called the light seed model. It says UHZ1 started as a normal stellar black hole, a few dozen solar masses. Then it fed at the Eddington limit for its entire life without ever slowing down. A perfect, uninterrupted growth curve. For this to work, the seed had to form within the first 50 million years after the Big Bang, and it had to swallow gas at the theoretical maximum, non-stop, for 400 million years. No pauses, no mergers, no competition. The math is possible. The astrophysics is not. Real black holes stall. Real accretion disks flicker. The light seed model requires a physical process that has never been observed. Something would have to feed a stellar black hole faster and cleaner than anything we have ever measured. The second idea is called the heavy seed model. It says black holes at the dawn of time did not form from stars at all. They formed by direct collapse. A huge cloud of primordial gas. Cold, dense, undisturbed by radiation. Instead of fragmenting into thousands of stars, it fell in on itself as a single object. 100,000 to 1 million solar masses in one gravitational event. No stellar phase, just black hole. A giant, born fully formed. This matches UHZ-1's mass better. But direct collapse requires very specific conditions. Zero star formation nearby, zero heavy elements, the exact right gas temperature. We have not confirmed one of these events happening. UHZ-1 may be the first indirect evidence. If direct collapse is real, it means the first supermassive black holes did not grow. They arrived. The third idea is stranger. Primordial black holes. Objects that did not form from stars or gas at all. They formed from density fluctuations in the fabric of the very early universe. Fractions of a second after the Big Bang. If those exist, they had 13 billion years to grow. No stellar limit applies. The concept is old. The evidence is thin. But UHZ-1 keeps the door open. Every one of these theories rewrites something. The light seed model rewrites how accretion works. The heavy seed model rewrites how the first structures formed. The primordial model rewrites the first second of the universe itself. UHZ-1 alone cannot decide which is correct. But JWST is not done looking. More objects are being found. Deeper into the dark ages, older, heavier. Every new detection is pulling that boundary earlier. The window in which black holes had to form is shrinking. Each one is another data point against the models we thought we understood. The dawn of time is not what we drew in the textbooks, and what we thought was empty space at the beginning of everything was not empty. Something was already there when the lights came on, and we do not yet know what it was.